Multiplying fractions. When we multiply fractions, unlike adding and subtracting fractions, we don't really care about the denominators being the same. So in this case, we can actually get right into the math. We don't have to worry about making the denominators the same in order to start. So we can actually go right ahead and start multiplying right here. So let me just switch this to my, okay, we're ready. All right, so we've got here 3 over 5 times 2 over 3. So in multiplication of fractions, what we want to do is we want to multiply the numerator, so the number at the top, against one another, and we want to multiply the denominators against one another. So in this case, we've got 3 times 2 equals 6, and we've got 3 times 5 equals 15. So now when we have this number, what we want to do is we want to reduce it to its simplest form. And so in order to reduce it to its simplest form, we're going to try to think about, is there a number that fits into both 6 and 15? And so we know what are the factors of 6. We know the factors of 6 are 6 times 1 equals 6. Okay. What is another number that can be multiplied to get a 6? We've got 2 times 3 equals 6. And 3 times 2 equals 6. So these are all of the numbers that we can use. Here's a 2, here's a 3, and here's a 6. Okay, to try to reduce this to a simplest form. So let's pick a number. Let's start with 6. Okay, so we know that 6 times 1 equals 6, but is there anything in the 6 time table that will also give us 15? Well, no, because 6 times 3 is already 18, and 6 times 2 is 12. So there's nothing in the 6 time table that we can use that will fit into both 6 and 15. So we'll know that the 6 one is not going to work. What about 2? Is there something in the 2 time table that would give us 6 and 15? Well, we know that 2 times 3 equals 6. Is there anything that we can multiply the 2 against that will give us 15? Well, no. There is no number because 2 times 7 is 14, and then 2 times 8 is 16, which goes over. So there's nothing in the 2 time table that can give us both a 6 and a 15. What about 3? Is there a number that we multiply the 3 against that will give us 6 and it will give us 15? Well, yes, we know that 3 times 2 equals 6. So we know that we could put a 2 right here. And what about 15? Is there anything in the 3 time table that gives us 15? Yes. 3 times 5. Let's write it right here. Oops. 3 times 5 equals 15. Which means that we can actually put a 5 right here. So this is our final answer when we're trying to multiply 3 over 5 times 2/3. Again, the answer is just you multiply the numerators against each other and you multiply the denominators against each other. It gives us 6 over 15. We can reduce that to its lowest form or lowest term, which is 2 over 5, and we did that by finding a number that can, when we multiply against another number, it can give us a 6 and it can give us a 15. And we know that 3 times 2 is 6 and 3 times 5 is 15. Okay, so what about when we have a fraction that's being multiplied against a whole number? So we've got 2/3 multiplied by 8. How do we go about doing that? Okay, so the first thing that we're going to do is we're going to actually rewrite our question so that it's easier for us to follow. So we've got here a 2 over 3 times 8. Okay, so we've got a whole number right there. So one thing that we need to remember is that whole numbers are really it's that whole number over 1. In other words, it doesn't matter what the whole number is, it's always the same. So 8 is the same thing as 8 over 1. Okay, if we had a different number, if we had 9, it would be 9 over 1. If we had a 5, it would be 5 over 1. If we had 50, it would 50 over 1. So any whole number will always be the same as that number over 1. So now that we have that 8 over 1, we've put it into a fraction, then now we can do our multiplication. We're going to multiply the numerators against each other and the denominators against each other. So right here we've got 16 over 3, and that's our answer. Now, here we've got two large fractions to multiply. We've got 6 over 25 times 5 over 30. And dealing with large fractions can sometimes be very overwhelming. So for example, if we were to use, do this calculation the way that we've learned, which is multiplying the numerator times the numerator and the denominator times the denominator, we would end up with 30 because 6 times 5 is 30, and 750 because 25 times 30 is 750. And so we know we probably have to reduce this even further. That's a very large number. Most likely it can be reduced. The problem is it's such a large number that we have no idea how to reduce it. We have no idea, okay, what number would actually fit, what timetable will actually work for both of these. We may not be sure. We may spend a lot of time trying to figure it out. But there's a way that we can actually make it easier for ourselves, which is reducing these fractions before we even start to multiply. So how do we do that? Okay, so let me just change here my color so that you guys see what we're going to be doing. Okay, so we got 6 over 25 and 5 over 30. So what we're going to do to start reducing the fraction before, this is only when we start before multiplying, is we're going to look across like this, okay? So we're going to look at the fraction across, and we're going to look at the fraction across this way. And so when we look at across, we want to see what number fits into 6 and also fits into 30. And so when we look at it across, we know that, okay, wait, 6 goes into 6 one time, and 6 goes into 30 5 times. Okay, what about across this way? What number, when we look at this fraction, what number goes into 5 and 25? Well, 5. The 5 timetable tells us that 5 goes into 5 one time, and 5 goes into 25 5 times, because 5 times 5 is 25. Now we can do our multiplication. So we multiply the numerators against each other. That gives us 1, because 1 times 1 is 1. And we multiply the denominators, and that gives us 25, because 5 times 5 is 25. And so look how quickly we got to our final answer. That's 1 over 25, which means had we gone the long way, what would have worked here would have been the timetable of 30. Now, nobody knows their 30 timetable by heart, but 30 would have worked. 30 goes into 30 one time, and 30 goes into 750 25 times. So at the end of the day, we would have gotten to the same result. We probably would have gone, reducing this in various steps to get to the 1 over 25. So look how much easier we can do it when we just start reducing the fraction before we start multiplying. Okay, so now we are going to try to practice or apply everything that we've learned so far. So we're going to look at this question, and before we start multiplying, we're going to take a look and see if we can actually reduce the fraction before we actually start multiplying. So we're going to go the easy route, which is let's reduce it before we start multiplying. So I'm going to grab my other color here so that we see what we're doing. Okay, so when we look at our fraction, in order to reduce, I said we're going to take a look at this as a cross. We're going to look at the fraction this way across so that we know if we can go ahead and reduce. So let's look at the 3 and the 6. Can we reduce? Is there something that we can do to make it smaller? Is there a timetable that goes into the 3 and the 6 as well? And so the answer is yes, 3. 3 goes into 3 one time. 3 goes into 6 2 times. Why? Because 3 times 1 is 3, and 3 times 2 is 6. Okay, perfect. Now, if we go across this way, we got to ask ourselves, is there a timetable that goes both into 5 and into 15? Well, yes. The 5 timetable goes into 5 and goes into 15. So 5 times 1 is 5. 5 goes into 5 one time. And 5 times 3 is 15, which means that 5 goes into 15 3 times. Okay, now we've reduced our fractions. Now we can actually go ahead and multiply. And we don't do this by doing a cross multiplication. We're still going to multiply the numerator times the numerator. So let's rewrite it first so that we can see what we're doing. So we've got 1 over 3 now times 1 over 2. That's how we got it. Now we can multiply our numerator times our numerator, which is 1. 1 times 1 is 1. And our denominator times our denominator, which is 6, because 3 times 2 is 6. Well done.